I'm going to show you how to solve linear equations. And if you haven't seen this before, linear equations are equations that look like this. Ax plus b equals 0. And here a and b are real numbers. Okay, so the x is what I call my variable. And depending on your equation, it may not actually be an x, but that's kind of like the mystery number that we don't know. It's the number that we're trying to find to make this equation a true statement. So these are conditional statements. And one way you have to think about this is that I'm allowed to work on both sides of the equation as long as I keep things balanced. So if I add 5 pounds on this side, I need to add 5 pounds to that side to keep this to make sure this is a balanced equation. So for example, in this first one, part A, we have 3x minus 1 equals 8. Okay, so the strategy is to get x by itself. Okay, so to do that in this first one, I need to firstly get rid of the negative 1. So to do that, I'm going to add 1. But remember, if I do that to one side, I have to do it to both. So I'm going to add 1 on the left and on the right. And when I do that, I end up with 3x equals 9. From there, to get rid of the 3, I can't subtract because this is multiplication. To undo multiplication, I needed to do division. So then I end up finally with x equals 9 divided by 3, which is 3. So there's my solution. If you wanted to write this as a solution set, and depending on your book, you'd write it like this in squiggly brackets. Okay, so we can look at some more examples, and they follow the same strategy. Okay, so to start question B, first I need to distribute the negative 3 and also the 7, and this is called the distribution property. And so what I'm going to do first of all is I'm going to say that I have negative 3 times 2t, so that gives me a negative 6t, and then negative 3 times negative 4 gives you a positive 12, and it's very easy to forget to distribute the negatives there. So make sure that you're careful with that. And then distributing the 7, I end up with 7 minus 7t. From there, I play the same game that I did in part A. I need to get the t's by themselves on one side and everything else on the other. So I'm going to add 7t to both sides. And I'm subtracting 12 from both sides. And when I do that, hopefully I'll get something that will be helpful. Let's see, I end up with negative 6t plus 7t is 1t. The 12s cancel out, and then end up with 7 negative 12, which gives me a negative 5, and then the 7t's cancel out. So I end up with t equals negative 5 as my solution. And again, if you wanted to write this as a solution set, that would be just negative 5 and braces. So in part C, again, I need to apply the distribution property, and I end up with 3w plus 5 equals 2w plus 6 minus 4. Okay, so now from there, I'm going to bring over my 2w, and so I have 3w minus 2w ends up being 1w, and I subtract my 5. Okay, so I have 6 minus 4, which is 2, minus 5 gives me a negative 3. Let me write that a little better. Negative 3. Okay, and there's my solution. And we worked this one kind of quickly, so you may be wondering, did I actually do this right? So you always feel free to check your work, and I think this is a good idea. So here I'm going to just to check to see if negative 3 actually works. I'm going to plug in negative 3 for w, and hopefully both sides of this equation end up being the same thing. Okay, so on the left-hand side, notice I have 3 times negative 3, which is negative 9, plus 5 gives me a negative 4. And on the right-hand side, I have 2 times, well, negative 3 plus 3 is 0, so that all becomes 0, and I end up with negative 4 equals negative 4. There, it worked out. Okay, now let's look at part D. And I think I'm missing a parenthesis here because I want to distribute again. I'm going to have to distribute this 3. And this time I end up with 3x plus 5 equals 3x plus 3x plus 3 times 3, which is 9, minus 5. So I end up with a 3x plus 5 equals to 3x plus 4. And if you start subtracting out, you'll notice I subtract out the 3x's, I get 0 on one side, subtract the negative 5 over, and get negative 1. And this is a contradiction. Alright, so this is a contradiction, which means we have no solution here. Okay, and if you want to look at the solution set is the empty set, which is the set with nothing in it. Okay? Alright, I hope that makes sense. Alright, now I want to look at one more. And this is part E. Y plus 5 over 4 equals 1 minus 5y over 6. And I hate this example, right? And you do too, because it has denominators, it has fractions. But I know a way to get rid of these denominators that are so pesky. What I can do on this side to get rid of the 4 is just to multiply by 4. Because the 4 in the denominator means it's divided by 4. But remember, if I do that to one side of my equation, I have to do it to the other. And on the right-hand side of the equation, I can multiply by 6 to cancel out the denominator. I better do that on the left-hand side as well. So I'm actually multiplying everything by 24. So now when I distribute this across on both sides, on the left-hand side, my 4's cancel out, and I'm left with 6 times y plus 5. And on the right-hand side, my 6's cancel out, and I'm left with 4 times 1 minus 5y. From there, this is the same thing that we've done in the other examples. Okay, so I'm going to distribute my 6. I get 6y plus 30 equals, on the other side, distribute my 4, end up with 4 minus 20y. Okay, now I need to bring over my negative 20y, and I end up with, let's see, 26y. And on the other side, I'm subtracting a 30, so I end up with a 4 minus 30, which is a negative 26. So now I want to divide both sides, I end up with y equals negative 1. Okay, and if you want to write it as a solution set, we know then that's just going to simply be negative 1 in squiggly brackets. Alright, I hope these make sense. I'm trying to show you kind of the things to expect. Linear equations kind of follow a very familiar pattern after you do several of them. If you have any questions, I'd be glad to help, and thanks for watching.